Ozone Formation and Depletion by Lillian, Chloe, Zainab, and Francois.
15 to 35 kilometers above Earth's surface, a gas called ozone surrounds the planet. The ozone layer acts as a barrier between Earth and ultraviolet radiation from the sun. However, pollution has caused the ozone layer to thin, exposing life on Earth to dangerous radiation. Earth's atmosphere is made up of 6 layers. The second layer, called the stratosphere, contains the ozone layer. The ozone layer is made up of a highly reactive molecule called ozone, which contains 3 oxygen atoms. Ozone is a trace gas in the atmosphere. There are only about 3 molecules for every 10 million molecules of air.
How is ozone formed? Ozone is formed in both natural and man-made ways. The natural way is from a 2-step reactive process where the UV radiation interacts with an oxygen molecule. On the other hand, the man-made way is through air pollution, which these are also known as oxides of nitrogen and volatile organic compounds. Oxides of nitrogen are a mixture of 2 gases, nitrogen and oxygen. These are formed or produced in a combustion process. An example of this is the exhaust gas from cars and trucks. Volatile organic compounds, on the other hand, are gases emitted from certain solids or liquids, such as paints, varnishes, and some aerosols. Depending on the location, these can be good or bad. Good ozone, which is found in the stratospheric layer, which is the layer directly above the troposphere layer. As you can see on the diagram to the right, it shows how this good ozone is produced. It is produced when the UV rays break apart an ozone molecule, separating it into 2 oxygen molecules, 2 oxygen atoms. Then these atoms will then combine with an oxygen molecule, creating an ozone molecule, or O3. This creates a layer which is commonly known as the ozone layer.
Bad ozone. Bad ozone is located in the troposphere, which is the layer closest to the Earth's surface. Bad ozone is also known as the ground-level ozone layer. Bad ozone is an air pollutant which is harmful to breathe since it damages crops, trees, and other vegetation, and it can trigger a variety of health issues, such as asthma. Ground-level or tropospheric ozone is created by chemical reaction between oxides of nitrogen and volatile organic compounds. The combination of these chemicals and the presence of sunlight forms ozone. And the picture over here explains the bad ozone chemical reaction in much more details, like how sunlight affects sunlight plus all nitrogen oxides plus volatile organic compounds forms ozone. So chemical reaction of ozone formation. Ozone is formed throughout the atmosphere in multi-step chemical process, which requires sunlight. In the troposphere, the process begins with an oxygen molecule being broken apart by ultraviolet radiation from the sun. In the lower atmosphere, which is troposphere, ozone is formed by a different set of chemical reaction that involves natural occurring gases and those forms pollutant sources. And so ground level of troposphere ozone is created by chemical reaction between oxides of nitrogen and volatile organic compounds. The combination of these chemicals in the presence of sunlight forms ozone. And so the chemical reaction of CFCs reacting with ozone to cause ozone depletion. CFC stands for chlorofluorocarbons, and chlorofluorocarbons is composed by chlorine, fluorine, and carbons. So CFC breaks up only through sunlight, which divides their molecule, causing the release of chlorine. And once the chlorine is released, it's able to react with ozone to form chlorine monoxide and oxygen. When a molecule of chlorine monoxide meets another molecule of oxygen, it breaks up, releasing chlorine, which can destroy another molecule of ozone, creating the catalytic cycle of chlorine.
My name is Francois Domingo, and I will be doing slide number 6. How does ozone absorb ultraviolet radiation from the sun? Basically, the ozone layer absorbs the UV radiation before it reaches the ground. Ozone can be considered as sunscreen or as a sponge. There are 3 types of ozone. There is UVA, there is UVB, and UVC. Ozone absorbs more than 99% of UVC rays, and those UVC rays are the most dangerous. Although ozone absorbs about 90% of UVB rays, that 10% is a huge problem because it causes sunburns and triggers skin cancer. And ozone absorbs about 50% of UVA rays. So when ozone is created by ultraviolet radiation in the stratosphere. And when those ultraviolet rays hit ordinary oxygen molecules, which is O2, the molecule is split into 2 single oxygen atoms, which is known as atomic oxygen. Then an oxygen molecule combines with another oxygen molecule to form an ozone molecule. And since there is so much oxygen and ozone in our atmosphere, ultraviolet rays are absorbed in the stratosphere. Basically, when those UV rays hit oxygen molecules, it's split into oxygen atoms and they combine with one another to form an ozone molecule. In conclusion, the huge amount of ozone in our atmosphere is absorbing the UV rays.
The depletion of ozone layer. Gradual thinning of Earth's ozone layer in the upper atmosphere caused by the release of chemical compounds containing chlorine or bromine from industry and other human activities. The thinning is most pronounced in the polar regions, especially over Antarctica. The effects of ozone depletion. Ozone depletion is a major environmental problem because it increases the amount of UV radiation that reaches Earth's surface, which increases the rate of skin cancer, eye cataracts, and genetic and immune system damage. What is Montreal Protocol? It is an international agreement finalized in 1987. It's banning CFCs and other ozone-depleting substances, and also to reduce their concentration in the atmosphere to help protect the Earth's ozone layer. The agreement set a mandatory timetable for the phasing out of main ozone-depleting substances and provided money to developing countries to help them phase out these substances.